Hello guys, so today we are here to solve our daily LeetCode challenge for the day. So today's challenge is Bitwise XOR of all pairings. Okay, in this we are given two zero-indexed arrays nums1 and nums2. Okay, and these arrays consist of non-negative integers. And then it is saying there exists another array. This array is not given. Okay, in the parameter to the function call which will be writing just now, there are only two arrays, but in the problem statement it is mentioning there exists another array. This array is helping us to imagine the things. Okay, for that only this he has mentioned it, and it is saying that which contains the bitwise XOR of all pair of integers between nums1 and nums2. So this contains the bitwise XOR of all pairs of integers between nums1 and nums2. Bitwise XOR of all pairing of integers between nums1 and nums2. Okay, so and then it is asking return the bitwise XOR of all integers in nums1. So basically what this is asking, that you have this result declared which can be which you can make it equal to 0. You can define it equal to be 0, and then you have this loop which creates a pair of nums1 element and for int j nums2 element. Okay, and then with the result, so first of all you do the I XOR j, and that value should be XORed with the result. Okay, and then you finally return the result. Okay, so see, there are these two nested loops. Okay, so the complexity of this is going to be n cross m, where n and m are the length of the nums1 and nums2 respectively. So let's see whether this is working fine or not. So this is working fine. Okay, this is what the problem is asking and we are doing. So it's going as per the problem description, so we are doing fine and it is being accepted. But the problem is, this is quadratic running time. This quadratic asymptotic running time is a problem. If the instance of the input becomes much larger, then the problem will be in trouble. We may face TLE. So let's just try to submit it and see what's happening here. So now actually this is what we are anticipating. Okay, but you know this problem need not be solved like this. Okay, we can solve it in a very different way. And how can we do that? So let me explain it here. So in order to solve this problem, what we can do, we can create n is equal to nums1 dot length, m is equal to nums2 dot length. Okay, like this. And then what we can do, that we can do something. See, one thing I would like to mention about XOR. Okay, so if you are doing XOR, okay, so one must be very very clear about this, that XOR of a number with itself is equal to 0. Okay, and XORing any number, okay, even number of times will be resulting in 0. But if we XOR a number odd number of times, let's say 3 times, okay, then we'll get back the number itself. Okay, so these are different things about XOR. Okay, which we must be keeping in mind. And okay, so if you see this this example 2 1 3 10 2 5 0, so in this 2 is being XORed with all the other numbers. Okay, and the numbers in this is 4. So 2 is joined with 10, 2 is joined with 2, 2 is joined with 5, 2 is joined with 0. So see, 2 is occurring 4 times, okay? 1 is also occurring 4 times, and 3 is also occurring 4 times. But this, in this pairing 10 to 5 0, this is occurring, one time, because 10 XOR 2, then XOR 10 XOR 1, XOR 10 XOR 3. So there are, 3 pairings of 10, okay? So if we write it like this, if we expand this pairing, let me just do it, okay? So first of all, we'll have 2 XOR 10, then again XOR 2 XOR again 2 XOR 2, XOR 2 XOR 5, XOR 2 XOR 0, okay, XOR 1 XOR 10, XOR 1 XOR 2, XOR 1 XOR 5, XOR 1 XOR 0. So see, in this 2 is occurring here, 2 is occurring here, and 2 is occurring here, okay? This 2 is there, but due to these two, 2 XOR 2 XOR 2, this will be equal to 2, and 10 is occurring 2 times, okay? 10 is also, occurring, and here we have, so, it will be other values also, it will be and so on kind of thing. Okay, so if you can imagine this thing, so in this 2 XOR is occurring, 2 is occurring 4 times because there are 4 values. 1 XOR is occurring 4 times because there are 4 values. 3 is also occurring 4 times because there are 4 values in this other array. But all these 10, 2, 5, 0, these are occurring 3 times. So because of our, understanding that, if something is occurring even odd number of times, it will be that value itself. So we can, take this n and 1 is equal to 0, okay? So this is 1 and m and 1 is equal to 0, okay? Then we'll be returning 0. Why? Because then all the pairings will be happening even number of times. But if suppose, we'll copy this. If suppose this is occurring 1 time and the other thing is occurring 0 time, so we'll be, having XOR of, so this is occurring 1 time. It means the value of num2 will be occurring, it will be repeated odd number of times, so it will be nums2, okay? And then else if, let's just copy this. Then it will be XOR of nums1, else we'll do a total XOR nums1 nums2, okay? That's it, okay? So we don't have to have this result declared over here, okay? So let me just write the private int XOR of int array arr for int I nums arr result zar I, and then we'll return the result, else private int total zar int nums1 nums2. So in this also we don't have to use a nested loop. What we can do, that we can first find the zar of this for int I nums1 result I, and then for int I nums2 result okay, and then we'll have to return the result. Okay, so see, nowhere we are using nested loop, we are using one loop after the other. Why we are doing that? Because see, if we are having both the counts odd times, then it is as good as individual numbers zarred, and then after that the zarring of the numbers from the other array, and that's what we are doing, and we are returning the result. So let me just run this and show it to you how it is happening. So let me use the keyword return over here, and then here also the word return, and then here also return it. Okay, so let me just run this. Entire perfect. Perfect. So this is the way that we are going to solve this, and this is basically utilizing the properties of zar, and the property that we are using is zar of a number with itself is 0. Zarring a number even number of times results in 0, and zarring a number odd number of times results in the number itself. So if you are knowing these three properties, then we will be able to very easily have the insight to solve this problem. And of course, the basic thing about zar is that we need to know that zarring 2 bits results in 1 if the bits are different. It results in 0 if the bits are the same. So that is the basic thing about zar which you must know. So with this, thanking you, thanks a lot, happy coding, best wishes.